Okay, everyone, it's a big week. It is launch week, launch day, in fact, when I'm recording this for my new book, The Ethical Nightmare Challenge. So, what we're going to do for this week is I'm going to give you the audiobook version of the dedication, the introduction, and chapter one. So you get a taste of what this book is about and whether I'm a decent writer, whether the book is of any interest, etc. So, I hope you love it. I'm not going to tell you about the book because you're going to learn about what the book is very early on. And that's it. Go have a listen. And if you like it, well, you can buy the book at Amazon, other places as well, of course. And that's it. If you love the book, hate the book, you just want to give some feedback on it, you can always email me at em@reedblackman.com. All right. I hope you like it. Dedication. To Little and Bada, I love you dearly. But if either of you ever come home holding hands with a robot, you're out of this family.
But Daddy, I love him!
It's not a him, damn it, it's an it. The Ethical Nightmare Challenge, How to Avoid the Worst of AI by Reed Blackman. Introduction. Suppose I have a cat, and you're kind enough to give me a cat guidebook. It works well, I'm happy, my cat is happy. And then I get a tiger and I come to you and say, hey, I got a tiger. I need you to update the cat guidebook to include tigers. What would you say? Would you say, sure, no problem, they're both felines after all? Or would you look at me, bewildered, fire in your eyes, and exclaim, are you nuts? These are widely different beasts. You need a new guide altogether. Here's where we are in the AI ethics or responsible AI world. We built AI guidebooks for narrow or traditional AI, the kind that came out before ChatGPT burst onto the scene. Upon the burst, leaders said, we need you to update our AI guidebook for generative AI. Sure, we said, we'll make it fit. Now leaders say, we're doing agentic AI. We need you to update the guidebook again. And what we should say in reply is, let me tell you a story about a cat and a tiger. But wait, I'm leaping too far ahead. Let's turn back. Or better, let's leap down the rabbit hole. Prior to November of 2022, or as some in Silicon Valley refer to it, in the year of our AI Lord 1 BGPT, data scientists and businesses were excited about what's now called narrow or traditional AI. This is the kind of AI used to recognize your face at airport security, identify broken bones in x-rays, and score resumes. The technology was, and continues to be, quite powerful. But it isn't without its risks. And so people like me went to work figuring out what those risks are, where they come from, and what to do about them. I even wrote a book about this, Ethical Machines, which at a minimum was decent training data for AI. Fast forward to one AGPT, and there's upheaval in the AI world. In fact, in the whole world. People won't shut the hell up about AI. With generative AI, the opportunities and risks exploded. Now it's in everyone's hands, and businesses are eager to use it for everything from, well, just everything. Looking to hire someone? Need to talk to a customer? Write an email? Outsource love? There's an AI pilot for that. But for those in the know, the excitement was tempered with wisdom. Take the chief information officer of a renowned healthcare provider. When we met for dinner in the early days of this brave new world, he was exasperated. His board was demanding generative AI innovation. If he could push the envelope with this frontier technology, the executives told him, they could save lives, boost their reputation, and ensure they wouldn't fall behind their competition. He shared their excitement, but he was also acutely alive to the risks in a way they weren't. First, there are familiar risks, such as privacy violations. Healthcare is just a tiny bit regulated when it comes to its data. And biased AI, for which United Healthcare got burned in 2019 and again in 2023. Second, new to the game were AI hallucinations, in which an AI chatbot outputs false information. Our AI lord is closer to the unreliable and questionably motivated mythical Greek gods than the god of most of today's major religions. Imagine, the CIO said, AI hallucinating in a clinical context. A doctor consults a chatbot that just makes up diseases or treatment plans. Unhelpful would be one thing, but this is dangerous. He sighed and put his head in his hands. At the time, I could only echo his concerns. I would have been lying had I told him I knew all, or even most, of the answers. A few months later, I was advising an executive in the legal department of a Fortune 500 consumer packaged goods company. As an attorney, she wasn't in the same hot seat as the CIO. Lawyers are rarely relied upon to innovate. But she was responsible for the company's brand and the people it affects. She told me that, since ChatGPT's release, and given her company's propensity to chase shiny new technologies, quote, nothing's on fire, but I feel like everyone's holding a flamethrower, end quote. Fast forward to 2024, Sorry, my lord, I mean to AGPT, and I'm speaking with an executive at a Fortune 100 entertainment company. He spent his career innovating, and he's excited about the possibilities of AI. But in an industry where issues of IP violations and job loss cause temperatures to rise and work to grind to a halt, recall the SAG-AFTRA strike of 2023, in which the union fought for its members' rights not to be digitally duplicated by AI without consent, using AI in the wrong way could be catastrophic. As he said to me, quote, "I want people to keep doing the amazing work they're doing. I also really don't want them to piss off our creative community or our investors," end quote. Were these people panicking for no reason? Are they chicken littles naively proclaiming the sky is falling? Not quite. The risks are materializing. Air Canada released a customer service chatbot that hallucinated elements of its bereavement fare policy. A customer sued Air Canada after he was misinformed by the chatbot and couldn't recoup his fare. The company shockingly tried to blame it on the chatbot and exclude themselves from accountability. Thankfully, the judge wasn't insane and found against Air Canada. A New York lawyer argued his case using, unbeknownst to him, AI hallucinated case law. The judge was not pleased, though the financial penalty the lawyer incurred paled in comparison to the reputational loss he suffered from his legal faux pas going viral. At the time of writing, Workday is facing down a class action lawsuit for discriminatory hiring practices in which AI is used. Similarly, in January 2026, a class action lawsuit was filed against Eightfold AI, a company that uses AI to assist its corporate clients in vetting job applications. In October 2025, the accounting firm Deloitte was in the news for including hallucinated material in a report to the Australian government. Spurred by friendly competition among partners, November 2025 saw another group within Deloitte doing the same for the Canadian government. The Chicago Sun-Times and the Philadelphia Inquirer suffered reputational damage after they published book recommendations that were fabricated by AI. Cases are mounting. The MIT AI Risk Repository has been tracking AI risk incidents since 2015. They verified 1,181 incidents, ranging from cases of discrimination and toxicity, to privacy and security breaches, to human-computer interaction failures, such as over-reliance and unsafe use. What's more, the number of incidents per year are increasing. From 2015 to 2021, there were just 100. In 2023, there were 163. In 2024, that number jumped to 272, and 2025 closed out with 346 incidents. The trend is clear. All of this is occurring against two backdrops. The first is that every year, every month, sees advances in AI capabilities. Technologists are working feverishly not only to advance AI itself, but to advance the extent to which AI is integrated into everything we do. We're not just talking about an AI tool that data scientists build and a handful of people use. We're talking about AI ecosystems that are constantly growing and changing, ultimately impacting how we do our work and how we no longer do our work, how we work with each other, and how organizations impact their customers, their employees, and society at large. At the heart of this is not only generative AI, but what are now called AI agents or agentic AI. The second backdrop is that companies aren't ready to handle generative AI, let alone AI agents. I say this from both professional experience. My team and I have advised dozens of Fortune 500 companies and small and medium-sized businesses, SMBs, and the conversations I've had with dozens of leaders and colleagues behind closed doors. The existing AI risk management approaches I've encountered, whether one calls them AI ethical risk or responsible AI or AI governance programs, are utterly inadequate to the task at hand. Those programs worked well for narrow AI, faltered with generative AI, and crumble with agentic AI. So now you understand, at least a bit. We built AI ethical risk programs for narrow AI. We updated them for generative AI. Now, when we're asked to update them again for agentic AI, we need to say, let me tell you a story about a cat and a tiger. Where we'll land. My writing this book is meant to produce three outcomes for you. First, I want you to understand how the AI risk landscape is becoming increasingly insane and rapidly. We're moving headlong from the complicated to the complex, to a place where our ability to predict how AI will behave breaks down as AI ecosystems stack risks on top of risks. We'll get there in chapters 1 through 3. Second, I want you to understand how current approaches to manage the ethical, reputational, and legal risks of AI are crumbling as the technology advances. The programs companies have developed, including the ones my team and I have helped them develop, cannot be sustained in the face of all this change. Those programs suffer from a variety of failures, including their general inability to adapt to fast-paced change and the difficulty organizations face in scaling those would-be solutions. This is the focus of Chapter 4. Third, I want you to understand and internalize a new solution for avoiding the worst of AI. I call both the need for a solution to the ever-evolving risks of AI and the solution itself the ethical nightmare challenge, which I'll cover in chapters 5 through 7. The ethical nightmare challenge, which I'll sometimes refer to as the challenge or as the ENC, is straightforward. It asks leaders, 1, what are your organization's AI ethical nightmares? 2, what resources will you create to avoid them? 3, how will you train your people to use those resources effectively? In one way, the challenge sets a low bar. It does not require specifying the good and the right. No one needs to specify the ideal. Emerging from Plato's cave is not in the itinerary, nor is the grand and abstract goal of making the world a better place. All that is required is to avoid catastrophe. That said, though the bar is low in that respect, it nevertheless takes a good deal of effort to clear it. Such is the scope, severity, and probability of manifesting AI ethical nightmares, as the MIT Risk Repository demonstrates. But as with any great challenge worth rising to, this one comes with great rewards: the confident, non-reckless deployment of a transformative technology. There are a lot of things I love about the Ethical Nightmare Challenge, but I want to highlight 3 here. First, it's extraordinarily portable. Every person, every team, no matter the department or role, can and should ask and answer these questions to avoid the worst of AI. The board of directors could ask themselves, what are the ethical nightmares we need to avoid? What resources will we provide to help our organization avoid those nightmares? What training should be provided to our employees to use those resources effectively? The marketing or HR department can ask, what are marketing HR nightmares we want to avoid? What resources should we create to avoid them? How will we train our marketing or HR personnel to use those resources effectively? A project lead on an AI solution can ask, what nightmares might bad design and or use of this AI solution lead to? What resources do we need to create to avoid them? How do we need to train our developers and or end users to use those resources effectively? Second, this portability facilitates intra and cross-department communication and collaboration. Data scientists and human resources professionals and marketers and chief operation officers and directors can all talk about nightmare scenarios together. When they share a language, they can collaborate. As we'll see, this cross-departmental collaboration is essential to manage the AI ecosystems we're building. Third, it rapidly and straightforwardly drives action. There's no wondering about how do we translate values to action. The challenge is already action guiding in its 3 steps. It just needs someone, a project lead, a department head, a member of the C-suite, you, to say, this feels precarious. We need to make sure things don't go sideways. How can we do that? Answer, articulate your nightmares, develop the resources, train your people. This third point bears emphasizing. Endless meetings and conversations that go nowhere drive everyone up a wall. And what you'll see, especially in chapter 6, is that the method for asking and answering the 3 questions, and thereby avoiding the ethical nightmares of AI, can begin almost immediately. That's because, and this is something that deserves to be screamed from the rooftops, you don't need C-suite alignment or an enterprise-wide policy to get started. This means, depending on your tolerance for change, you may find the ethical nightmare challenge jarring. That's not how we do things, you might think. If you're in that camp, I offer the following. You don't need to start with C-suite alignment, but you can certainly end there. In this respect, the ethical nightmare challenge is like a lot of other initiatives in your organization. You try it here and there, and as you see success, you scale to other projects and other departments until it's established organization-wide. Further, as you'll see in chapter 4, and as you may know from other hair-ripping-out experience, starting with trying to secure C-suite alignment is a death sentence. This is due, on the one hand, to the years-long effort it takes to reach alignment, get a policy approved, and implement that policy, and on the other hand, to the speed at which AI evolves. If you cling to the old ways of avoiding very bad things, you'll crash right into them. So if, when you hear we need a new approach to AI risk, you raise a skeptical eyebrow, I get that. What's worked for decades has worked for decades. But everything works until it doesn't, and I'm about to show you why that time is now. My optimism. I've said a lot about catastrophe and failure. I put nightmare in the title of the book, for Christ's sakes. It can, as AI often does for people, feel overwhelming. And while this book does focus on nightmare avoidance, that focus is not born of skepticism, either in our ability to avoid the nightmares or in AI itself. I don't think the sky is falling, or at least it won't fall if we put the right structures in place. And I think that AI is incredible. I'm a frequent user of a variety of AI models. Some of the innovations that are on the table, especially those in healthcare and life sciences, are exciting and inspiring. I think untold millions of people can be helped. I think organizations of every shape and size stand to benefit a great deal from its use. But I won't pretend, as some salespeople in the AI ethics or responsible AI space do, that ethics makes you more innovative. Unfortunately, there are tons of ways to innovate beyond the ethical pale. If there weren't, there'd be no need for books like this. Instead, I like to think of the value of ethical nightmare avoidance by way of an analogy. I've been an avid rock climber for over 15 years, but I'm not Alex Honnold, who famously scales dizzyingly high, sheer, and difficult cliffs, and sometimes buildings, without a rope to save him if he breaks a piece of rock off with his hand or a foot slips. Me? Give me a rope. It doesn't push me up the wall, of course, but without it, I ain't climbing. Given how much is on the line, my wife and children, my parents, my sister and other family, my friends, my own goals in life, etc., combined with my own propensity to make mistakes while climbing, even small ones, it would be reckless of me to climb without a rope. So while the rope isn't improving my climbing, it enables my climbing. Rising to the Ethical Nightmare Challenge is a lot like this. It enables your organization to climb to great heights without the fear of going splat. One last note before proceeding. In the world of AI, there are more ethical nightmares than we can count. My mission is to give organizations a way of handling them. So this isn't a book that tackles all potential disasters associated with AI, such as human extinction, mass unemployment, deepfakes undermining trust in our informational ecosystem, bad actors launching wave after wave of cyber attacks, people marrying AI robots. The Ethical Nightmare Challenge is first and foremost a guide for leaders and organizations, be they in the C-suite, department heads, or project leads, to avoid the worst of AI in their respective jurisdictions. I'm not here to tell people what's right and wrong and to heed my commands. I'm here to enable leaders to tackle these issues themselves. Okay, buckle up. It's going to be a bumpy ride, but I promise, it's also going to be pretty damn fun. Just ask my grandmother. Chapter 1. AI risk made so simple, even my grandmother can understand it, and she's dead. The Ethical Nightmare Challenge is both a way of articulating a problem that needs to be solved and a framework for solving it. This means that, if the solution is to make any sense, you first must understand the problem to be solved. Thus, this chapter and the next two combine to achieve one overarching goal: to communicate how diabolically complex the AI risk landscape has become, so you can understand what a successful solution must accomplish. What AI is, or don't let technologists push you around with fancy words. In late 2023, I gave a particularly memorable presentation to the board of a Fortune 500 healthcare company. It stands out for three reasons. First, it was held at the chair's beautiful penthouse apartment in New York City, in which everyone was, reasonably, asked to remove their shoes. It's still the only keynote I've delivered both in person and in socks. Second, as I detailed the risks of AI, one board member jokingly said to another, loud enough for everyone to hear, "Can you tell him to stop talking? He's making me nervous." My presentation was preceded by the chief information officer giving the rest of the board an overview of AI. His presentation was comprehensive and accurate. He talked about convolutional neural networks, optical character recognition, natural language processing, large language models, and more. The problem was that, despite his best intentions, he was confusing the audience, the vast majority of which did not, to say the least, grow up with personal computers. To them, he was speaking a foreign language. He may as well have told them they lacked riz. This is a common problem with experts. When they speak to novices, they often can't do it with a great deal of intellectual empathy. They forget what it's like to be a beginner. Yes, sometimes technologists intentionally want to push people around to show how smart they are, or to wall off their work from the prying eyes of others. But more often, they just haven't been trained to talk to non-technologists about their work. Innocent and understandable as not knowing how to speak to beginners is, it's disastrous. It results in excluding people who need to be in the conversation about AI in general and AI risks in particular, whether we're talking about members of the board, or the CEO, or the head of HR, or the people in procurement. If people feel intimidated by AI and its risks, they can't help. Next. And to be clear, avoiding the ethical nightmares of AI requires their involvement. You aren't going to avoid the ethical nightmares of the marketing department if no one there can comfortably talk about AI. For all the fancy words, it all boils down to this: AI is software that learns by example. This is so important, I'm going to say it again, louder for those of you in the cheap seats. AI is software that learns by example. You know what software is. You use it all the time. Microsoft Office is software. Your Netflix app is software. Every website you've ever been to? Software. And you know what it means to learn by example. Kids do it all the time. They see examples of the word "the," and then they could recognize it in a sentence. They see examples of what pigs look like. and then they can identify them in pictures. You've seen examples of Impressionist paintings and can now, more or less, identify which paintings in a gallery are Impressionist. The notion of learning by example is well understood. AI is software that learns by example. That's 3 times, and I'm not going to stop. If you want AI to enable your photo software to recognize when you take a picture of your dog, then give it a bunch of photos of Pepe, and it will see Pepe in new photos you take. If you want AI to approve and deny mortgage applications, give it a bunch of examples of approved and denied mortgage applications, and it can spot the ones that should be approved when you give it new applications, hopefully. And if you want your AI to identify whether a bone is broken in x-rays, give it a bunch of examples of broken and unbroken bones in x-rays, and we'll get good at that too. These are all examples of narrow AI for the simple reason that they focus on a single task. This AI determines whether a bone is broken. This one predicts the likelihood a person will default on a mortgage. This one evaluates the probability that a job candidate will be a good employee, and so on. You'll also hear people refer to this as traditional or predictive AI. When it comes to generative AI, ChatGPT, Claude, or Gemini, or whatever you've tried, that too is software that learns by example. 4. ChatGPT and its ilk are quite good at stringing words together coherently because the software was given tons of examples of words being strung together coherently. Some generative AIs can string computer code together because they've been given lots of examples of computer code being strung together. They can organize and color pixels in a way that creates pictures of dogs because they've been given lots of examples of pixels being organized and colored in a way that creates pictures of dogs. Let's focus on generative AIs that create sentences and paragraphs. These are, as you probably know, large language models, or LLMs. If someone tells you that they have an AI that can talk to patients for therapeutic purposes, you now know that they must have given that AI a bunch of examples of words being strung together coherently that deal with topics like grief, loss, and depression. That's why, when you say to the AI, "I'm feeling really lost now that my mom is gone," it may reply with something like, "That sounds really hard," and not something that would be utterly incoherent like, "The frog ate my baby." That is a sentence, but it's not even close to the sort of sentences it saw in those examples that dealt with grief and loss. Similarly, if someone tells you they have an AI that talks about the destruction of humankind, you now know that they must have given that AI a bunch of examples of words being strung together coherently that deal with topics like destruction, death, and murder. Finally, if someone, like OpenAI, the creators of ChatGPT, tells you that an AI can be engaged with to talk about either the loss of your mother or the destruction of humankind, you now know that it was given a bunch of examples of words being strung together coherently about death in the context of losing a loved one and death in the context of an existential crisis for humankind. The same goes for any other kind of conversation you might have with an AI. Now you've learned that AI is software that learns by example, that's 5, by virtue of being given a bunch of examples. It really is, in essence, that simple. But look, if you want to sound a little fancy, you can do that. AI is software that learns by example, 6 and still more to go, is a very non-technical way of putting things. If you'd like to sound technical, you could use a fancy word such as data instead of example. Here's a lowbrow question you can ask someone who is telling you about the AI they created. What examples did you use to teach your AI? Here's the same question, but highbrow. What data did you use to teach your AI? And if you really want to raise your brow, ask, what data did you use to train your AI? The highbrow questions are fancy, but they mean the exact thing the lowbrow question does. That said, there's still a lot you probably don't understand at this point. There are different ways of getting AI to learn. For example, supervised and unsupervised learning. There's the math that underlies that learning, algorithms galore. There's the hardware required to learn in certain ways, about which NVIDIA, maker of computer chips, is very happy. We'll get into some of those details in the next chapter, but for the most part, if someone throws fancy words at you and you're not an academic, a student, an engineer, or a data scientist, they're either bad at communication or trying to intimidate you. Don't let them push you around. They're just talking about software that learns by example. Lucky number 7. How ethical nightmares emerge from what AI is. AI is software that learns by example. Okay, I'll stop now. Once you know that, you have a great deal of insight into how things might go well or poorly for an AI. If you give an AI bad examples, you'll get a bad, that is defective, AI. If you give it great examples, you'll get a good, that is functional, AI. If, for example, all the examples of your dog are highly pixelated photos of him from one angle in poor lighting conditions, the AI learning by those examples is going to be very bad at recognizing Pepe in photos. You need to give lots of examples. Different lighting conditions, different angles, his eyes open, his eyes closed, running, laying down, in full sploot, and so on. All else equal, the more examples you give, the better. Same with X-rays and words being strung together coherently. Bad examples equals defective AI. Good examples equals functional AI. Fancy translation? If your training data is not sufficiently representative of the array of contexts in which the AI will be deployed, your AI will output too many false positives and/or false negatives, or incoherent text, or truly bizarre images to be functional for the intended use case. If this were a book on how to develop an AI strategy or successful AI solutions, this is where we would start digging into various ways of making sure you have the organizational capacities to identify where it makes sense to use AI and how to ensure the AI solutions work, such as identifying problems that are plausibly solved with AI, breaking down data silos so you can use them to train your AIs, etc. But this isn't a book about how things might go well. It's a book about how things might go poorly. In fact, it's a book about how things might go terribly, nightmarishly wrong, even if the AI is otherwise functionally sound. Unfortunately, it's precisely because AI is software that learns by example that ethical nightmares aren't merely possible, they're probable. In some cases, they're guaranteed. Recognizing that ethical risks are built into software that learns by example is crucial for effective ethical nightmare avoidance. That's because if you're looking for ways that things could go bad, it makes sense to start that search where you already know the nightmares are likely to be found. Similarly, if I tell you that wildfires can start anywhere in the forest, but they're most likely to ignite near power lines and dry creek beds, it makes a whole lot of sense to start your inspection there. I covered some of this ground in Ethical Machines, especially issues around bias, explainability, and privacy, so I'll review a bit of that here and spend more time going deeper on risks pertinent to generative AI. In Chapter 3, we'll tackle risks that are specific to agentic AI. Bias. AI is software that learns by example. If you give your software that learns by example photos of Pepe in highly specific circumstances, then it won't recognize Pepe outside those circumstances. Similarly, if the examples you give AI of what people look like are only pictures of white men, then you'll get software that only recognizes white men and not, say, Asian women. If you only provide examples of the medical histories of 50-year-olds with diabetes in California, your AI won't know how to handle the medical histories of 75-year-olds with cancer in Appalachia. To take a slightly more complex example, if you A, give your AI examples of mortgage applications that were denied and approved, and B, it turns out that the applications of Black people were mostly denied and the applications of white people were mostly approved, then C, your software will learn from those examples that applications from Black people should probably be denied and applications from white people should probably be approved. These are real examples of bias in narrow or traditional AI, but the same issue occurs with generative AI. If you give your software that learns by example lots of examples of yellow cats and not so many examples of white cats, guess what color the cat will be when you ask it to generate an image of a cat? And if you give the software that learns by example lots of examples of words being strung together coherently in ways like Black people are criminals, Asian people are bad at driving, and Jews run the world, guess how it might put words together when you ask it about those kinds of people? Because AI is software that learns by example, and those examples can manifest various biases, it may learn and manifest those biases. It's not just possible, it's probable. In fact, it's already happened. Every generative AI has learned from examples that were generated by a society full of people who are underinformed, misinformed, racist, anti-Semitic, self-interested, and just plain stupid. Yes, it also learned from examples that were generated by a society full of people who are well-informed, educated, fair-minded, generous, inclusive, and brilliant. That's why software that learns by example can create incredibly smart outputs. But since the examples that AI learned from were generated by a very diverse population, from stupid to brilliant, from ignorant to well-informed, the software that learns by example reflects it all. There are, of course, various ways of identifying and mitigating the biases of AI. Lots of strategies, tactics, technical tools, and more are used on that front, which we'll discuss later. But the absolute necessity for such strategies and tools is precisely because bias is guaranteed to be built into any system that is software that learns by example. This is worth emphasizing. Bias is guaranteed. There's no such thing as perfectly unbiased, objective AI. The choices we make about how to train, test, and improve AI reflect value judgments about what is and isn't important, what counts as better, what good or good enough looks like. Want to create an AI that's more inclusive of historically marginalized people? That's a value judgment. Want to create an AI that eschews talk of belonging and inclusivity? That's a value judgment too. That's not to say that all value judgments are made equal or that they're all equally justified. It's simply to say that those value judgments exist, and we best make them carefully. Explainability / the black box. AI is software that learns by example, and it's always a lot of examples. And what it's learning is what patterns consistently arise across all the examples. But the patterns AI sees aren't the patterns we humans see. When my son sees lots of pictures of pigs, the patterns he notices are things like 4 short legs, corkscrew tails, and a bit chubby around the waist. The software that learns by example, however, is looking at mathematical patterns. If it's a pig identifying AI, it's looking at the thousands of pixels and the mathematical relations among those pixels in each of the pig photos to find the statistical pattern that is common across all those pictures. A large language model is doing something similar. To simplify a great deal, an LLM reviews all the words in a bonkers text corpus, all the books, magazine articles, blog posts, and internet pages, and looks for mathematical patterns. For instance, it may notice a high probability of the word thank being followed by the word you. Crank up the predictive capability, and the software can create plausible sounding sentences and paragraphs. Technically, it's recognizing patterns across tokens, which is something like subsets of words, but that fancy language isn't needed for our purposes. What makes AI so powerful, recognizing phenomenally complex mathematical patterns in mountains of data, is also exactly what makes it so difficult to understand. Those mathematical patterns are very long and complex, far too much to keep in our heads. Suppose, for instance, I give you a 50-page book that contains the entirety of a mathematical calculation for how inputting, tell me a story about how a bird and a fish fell in love but couldn't build a home, resulted in an output that contains the entire narrative of the doomed lovers. Then I ask you to describe how the software did that. The best you could do is shrug and point to the book. The explanation is too much for either of us to handle. This is known as the explainability or black box problem. The issue is that we understand the inputs, we understand the outputs, but we just don't understand what happens between the inputs and the outputs. In ethical machines, I explain why this is sometimes a problem and sometimes not. But here's the thing. While explainability for how narrow AI works can plausibly be had, explainability for generative AI is, at this point in time, virtually non-existent. This means that if for some reason, for example, regulatory requirements, you must have explainable AI for some particular use, such as mortgage lending, then generative AI is not an option for you. Privacy. AI is software that learns by example. I've definitely lost count. Those examples are often about people, and sometimes these examples are owned by other people. Translating to talk about data, AI often trains on data about people and data that is owned by people. If we think of privacy violations in relation to AI as essentially people having or using data in ways that are ethically, reputationally, or legally problematic, you can see how privacy violations are likely. That's presumably why Anthropic, creator of the popular LLM Claude, agreed to pay $1.5 billion to settle a lawsuit over its pirated use of copyrighted materials. Put slightly differently, given that the fuel of AI is data, and that data is often about people, and sometimes is the intellectual property of people other than the AI developers, privacy, copyright, and intellectual property violations are highly likely. In fact, not only are such privacy violations likely given how AI is created and used, but they're also likely because all that data may accidentally be leaked or intentionally stolen by bad actors. X's Grok leaked user conversations through Google Search in August 2025, while researchers found 7 vulnerabilities in OpenAI's ChatGPT later in the year. Hallucinations. AI is software that learns by example. Okay, even I think is a bit much now. In the case of generative AI, and LLMs in particular, the examples include a bonkers quantity of text. All the books, all the journals, all the internets. But what were these textual examples of? At the fundamental level, they were examples of how millions of people have put words together to make sentences and paragraphs. Here's how you put words together about World War II. Here's how you put words together about diagnosing patients with skin irritation symptoms. Here's how you put words together about cows, jumping, and the moon, and so on. The range of topics in relation to which words are put together is literally the entire range of topics humanity has ever written about. When we put words together, sometimes the words are put together to form a sentence, and sometimes we put words together to create a true sentence. Paris is the capital of France, or water is composed of hydrogen and oxygen, or Napoleon got his ass kicked in Russia. Other times we put words together to create a false sentence. South Carolina is north of Maine, or the earth is flat, or Reed Blackman is at least 6 feet tall. Now, whether a sentence is true or false, it's coherent. The false sentences are as intelligible as the true sentences. That's what allows us to say that they are false, after all. If they were gibberish, for instance, if someone would put words together like this, the cat wheelchair bonked red flowers, we couldn't say it was false. We'd just say it makes no sense. On the other hand, the earth is flat makes sense. It's just false. When companies create LLMs, the examples they give it are strings of words that, for the most part, make sense, even if they aren't true. So what LLMs learn is how to put words together in a way that makes sense, even if the resulting sentence isn't true. This is how we get AI hallucinations, LLM outputs that are intelligible but false. We saw examples of these in the introduction. Air Canada's chatbot hallucinated information about its bereavement fare policy. Deloitte research reports contained hallucinated information. AI hallucinations are common. Anyone who has used an LLM with any frequency has encountered them many times. And while data scientists employ various techniques to decrease the rate at which LLMs hallucinate, aka make stuff up or bullshit, more on this in the next chapter, hallucinations continue to pervade LLM outputs. Automation bias. There's a way in which hallucinations, by themselves, aren't a problem. If people were amazing at systematically checking the reliability or truthfulness of what an LLM says, then LLMs would just be an efficiency tool that says false things, which isn't a problem because their outputs are regularly checked. Unfortunately, people are not amazing in this regard. We are generally given to deferring to machines. We think something like this. This is a computer. It doesn't make mistakes. I'll go with what this says. This is called automation bias. This is the kind of thing that led GPS-compliant Philip Paxson, husband and father to then 9 and 7-year-old daughters, to drive over a bridge that had collapsed years ago. Paxson fell 20 feet to his death. In a similar but less tragic case, a man was following his GPS when he suddenly found himself 8 feet underwater in a lake. In the case of LLMs, the situation is worse for a variety of reasons. First, many people don't know that LLMs hallucinate. In those cases, over-reliance is bound to happen. Second, knowing that LLMs can output false information is not enough to stop people from automatically relying on them. People are lazy or busy and want quick answers, which is one reason to turn to an LLM in the first place. What's more, manually checking the veracity of outputs can be slow and take quite a bit of effort. It could also lead to rationalizing. Yeah, I know this thing makes stuff up, but this looks pretty good. I'm sure it's fine. Of course, I've never done any such thing. Third, automation bias is exacerbated by the tone of authority LLMs often manifest. LLMs are not only too frequently wrong, but too frequently confidently wrong. This may result partially from the LLM learning from examples of overly confident styles of writing that are rampant on social media and marketing materials. The best way to get blood out of your hair. And, of course you're wrong. And, it's well known that this is the only way to lose weight. The authoritative tone could also come from the creators of LLMs inserting a confident, quote-unquote, personality into the LLMs. And it could be the result of human reviewers grading LLM outputs, assigning high scores to confident-sounding outputs and lower scores to uncertain or hedging outputs. More on this in the next chapter. There are many possible contributing factors, but however an LLM acquired its authoritative tone, and however good it may feel to talk to something that is clear and confident, this seduction is dangerous. Finally, checking the veracity of the claims of an LLM cannot be automated. There is no software that can run a program that checks claims against reality. Verifying the truth or falsity of a claim must be done manually. The deliberation problem. AI is software that learns by example. At this point, you should blame my editor. Among the textual examples it learns from are examples of people engaging in reasoning. Thus, LLMs appear to have the power to deliberate, to present coherent reasoning that looks like thinking. But LLMs are not reasoners. They don't weigh evidence. They don't form conclusions on the basis of facts. They are not thinking. They are calculating. They are always engaging in next word prediction. It looks like reasoning, but it's just more of what we saw before, putting words together in a way that is coherent. And just as words can be put together to look like true sentences, they can be put together to look like good reasoning. But neither truth tracking nor reasoning is going on. This point is subtle, so let's take some time with it. LLMs are in the business of finding the next set of words that is maximally coherent with the words that came before it. Its outputs should make sense to the user. What's so startling about LLMs is that they can make sense without understanding what they're saying. An LLM doesn't understand its outputs, doesn't grasp the meanings of words. It's a surprisingly successful, though far from perfect, next words predictor. This means that when you ask an LLM for an explanation for why it recommended X, it doesn't give you an explanation for why it recommended X. It predicts the next words it thinks cohere with the conversation that has thus far transpired. It does not articulate the reasons it recommended X because it doesn't provide outputs for reasons. It does not deliberate or decide. It just predicts next word likelihood. it fabricates reasons, which, to the unsuspecting user, genuinely look like the reasons behind the outputs. So when an LLM provides an explanation for why it recommended X, it's yet another hallucination. This generates at least two problems. First, it's easy to get fooled by this. Suppose, for instance, a user overcomes their automation bias, laziness, and need for speed, and says to themselves, I know this thing can hallucinate, so I'm going to check it. And so the user begins probing the LLM for the reasons that gave its recommendations. Now the LLM patiently and authoritatively explains to the user its alleged rationale for its recommendation, and the user thinks, good then. So responsible of me. I knew to check its answer, and I did. I'm such a responsible user. And now we're back to where we were before their efforts to overcome their bias, laziness, and need for speed. Despite their attempts, they've succumbed to yet another hallucination. Second, sometimes it matters that a person deliberates. While there are some scenarios in which performance is all that matters, there are others where it matters to us, or at least some of us, that there's a person on the other end deliberating about how to treat us properly. In a criminal justice context, for instance, you might care not only that the judge gets the right answer, but also that she engages in deliberation. Her thinking about you and your case is part of what it is to be respected by the judge. Offloading that decision to a computer is, arguably, ethically objectionable. Similarly, we want good financial advice, but we also want to know that we're getting that advice from someone who's actively deliberating about what's best for us. We want the human-to-human relationship. Something about it is more comfortable or more natural or more trustworthy. That said, even if you don't feel this way, nonetheless, some of your organization's customers likely do. In that case, as a matter of respect for their wishes to maintain that human element, not replacing deliberative people with faux deliberative software is a good idea. The deliberation problem is in fact a particular manifestation of the hallucination problem combined with automation bias. But I think it's so easy for people to fall prey to it, it's worth calling attention to. Perhaps it's not a foundational problem, but it pours gasoline on the hallucination and automation bias fire. How ethical nightmares emerge from how people use AI. Understanding these inherent risks, bias, privacy violations, hallucinations, and the rest, is crucial for any organization deploying AI. But here's what many executives miss. Even if you could somehow create perfect AI software that learned from perfect examples, which you can't, you still face a second category of nightmares. These emerge not from flaws in the technology itself, but from the choices people and organizations make about what to do with that technology. A flawlessly functioning AI system can still create catastrophic outcomes if it's applied to the wrong problems or deployed without considering the broader consequences. It's impossible to list all those risks, but some examples are illustrative. If you use AI to create a self-driving car, maiming and killing pedestrians are risks with which you must contend. If you use AI to create autonomous weapon systems, say drones that assess what's happening in a combat situation and decide where best to shoot missiles, then killing non-combatants and one's own soldiers are risks to consider. If you create an AI chatbot that functions as a salesperson, then you run the risk of creating a manipulative AI, one that strings words together in whatever way it needs to make the sale, including creating false and misleading statements and omitting important ones. If you create an AI that creates deep fakes of anyone based on 30 seconds of video, then you run the risk of releasing a system that allows bad actors to wreak havoc by creating fake videos of politicians, celebrities, and their ex-lovers saying or doing things they have not actually said or done. You get the point. In identifying the risks of a given AI in a given context, you have to pay attention to both the risks that are built into AI and those that arise because of how we use it. The ground has been shifting beneath our feet. Now you know what AI is and how nightmares emerge both from what it is and how people use it. But moving from narrow to generative AI isn't just a matter of adding some new risks to the list. Hallucinations, the deliberation problem, etc. The sources of those risks, the likelihood of those risks becoming realities, and what can be done to avoid them has changed dramatically. Bringing out these underlying seismic shifts is what we turn to next. Thanks everyone for listening. I hope you enjoyed the episode, and I want to thank a few people who make this all possible. Delano Alexander, he's my producer. He does such an amazing job on everything that he touches. Garrett Ling is the sound engineer. That's honestly, he's too good for me. Athmia Jairam has joined us recently. He's helping us find the best guests to bring onto this podcast. And Ashley Wassilenko helps us organize all this, get people on the schedule, get people's bios, headshots, and really keeps the train on the track. So thanks, guys. Really appreciate all the hard work you do.